Good afternoon.
Hi there. Uh, uh, Drew, hi everybody. Very good afternoon.
Good to see you all. We give people a little while to join. So welcome. I think we just had another meeting, so there'll be a few people jumping from that. So I think we've got a couple of exciting topics. So Yogesh, just while we're waiting for people to join, um, I think we wanted to talk a little bit about PCIe today. And then I also have been working with Anil offline to talk about kind of next steps for how we attack in-band error logging. And so I think Anil has some thoughts on that as well that maybe we can discuss. Uh, is that okay with you?
Yeah, sounds good to me.
And I think what we want to do with Anil is, what Anil and I talked about is like kind of review the process and and figure out like the next step for the discussion, which I think is going to be he'll have some pain points that he wants to talk about. I don't want to speak too much for Anil, but that's what I encouraged him to think about is, for in-band logging, we know that there are problems, but since he cares more about it, he's relying more upon it. It would be helpful to have him work through where he's seeing issues, and then um, we can list the pain points and then work through the pain points. And I hope this is okay, but I'm encouraging Anil to contribute the in-band things to our current requirements document. So we just have one doc. Um, I think that would end up being better. So I hope that's not controversial. But I think as we sort out the in-band stuff, we'll just add it.
Yeah, I think that's what we discussed many times, that we will revise the document. That's what we said in the current version of document also, that the
Yeah.
future version will be,
Extend.
appended in-band requirements. So that's been
Okay.
planned all along. Yeah.
Okay. Thanks. Good. I didn't. I was hoping I wasn't screwing anything up. So that's reassuring. Okay. So we'll do that with him. And so uh, when talking about it, I realized that there's probably some overlap with some of the PCIe problems and in-band logging. Here's the rich irony: is I'm saying I don't care about. Uh, so I'm laughing at myself here, and no one else. But I said, oh, I don't care about in-band error logging, but of course I care about what the OS sees happening in PCIe. So I'm going to promptly eat my words and say, some of his stuff's kind of interesting, and we at Google are even wanting to propose uh, a series of improvements to the AER driver in the Linux kernel to enable us to get logs out of it to some higher level tool. Uh, so we can see the OS's view of what's happening with devices. And we want that out of band too, but the OS needs to see it and react to things. So I think it's going to work pretty nice. I was pretty encouraged after I spoke to him that there's a lot of meat to the topic, and it'll end up being a very productive discussion. So hopefully that's not too controversial.
No, nothing. None of that is. We just need to start writing things down, listing things down, and start reviewing.
Sounds
That's
good.
the whole point of being here, so we can review things together and agree upon those, right?
Yeah, absolutely. Okay. Well, so then the other thing, and I know Anil is going to be here eventually, and I think Rama as well. Um, we want to talk about PCIe error handling, and so um, it's hard for me to overstate how excited I am that Erwin's here today, because Erwin has been doing some stuff with us to address PCIe error handling, and I'm kind of bummed that I really wish Mark Fletcher but at the end of the year, the folks at HPE start winding down. Um, but but I wish you know, Scott Ramsey and Mark were here. But I think we can get started. Um, but you know, I think Erwin's been doing some stuff with us to describe how PCIe should work that I'm really excited about. And Yogesh, I don't know if you had a chance to look at the introduction slide that I made, but if it's okay, I'd like to kind of introduce the topic with that one slide, and then shift to Erwin.
Yeah, go for it.
Is that okay?
Yeah,
Yeah.
I think that's a good plan.
Okay.
And
And so this, you know, we've got PCIe work to do. Uh, and I don't want to shortcut the process of looking at um, the pain points, but there's some obvious stuff we need to fix. And so this is my opinion. Uh, hopefully, can you see the doc I'm sharing?
Yeah, we can.
Oh, great. So this is my opinion. I am uh, happy to be corrected, but uh, you know, what I've noticed is that we're all suffering. And I think the PCIe spec has a lot of flexibility. It's designed to support everything. You know, Raspberry Pi 5 has, I think, a buy two PCIe link on it. And it's everything from laptops to accelerators to data center products. And that requires flexibility. But that flexibility has created ambiguity. And what that means is that devices use error signals inconsistently. We don't have a very uniform meaning for what a device error is versus malformed TLP versus anything else. Uh, so that makes things hard, and that inconsistency also is reflected in that there's no single way to configure PCI air handling to work well for data center OSs. And so,
when you say devices, Drew, you mean what?
I mean, PCIe devices like bus device function.
So any PCIe agent, not just okay.
Yeah, I think I can clarify that. I mean, yeah, and it's just that Google, we went through and started looking at some of the devices that we're working with, and we looked at some of the errors that PCIe has supports, and we were scratching our heads at some point, saying, "What does this mean? Like, what error should we use here?" If I'm talking to an ASIC designer, I don't have a really good handle for what I even want in terms of PCI errors from the device we're designing.
So you don't necessarily mean root complexes. You probably are leaning more towards endpoints. Is that what you are trying to get at?
Yeah, that's what I call it, a PCI device, I guess.
Okay, so endpoints. Okay, yeah. So
yeah, I can. Yeah, thank you. And you know, that's made things hard for us because what happens? So here's what happens at Google: we roll out a new product, we think it's awesome, it's successful, everything's going great, and then someone plugs a new PCIe card into those machines, and our life is pain, and we're getting unexpected behavior. We don't even know what we want. And so we scratch our heads, and some hero comes and tweaks the BIOS and messes with the driver, and the problem goes away until someone introduces some other new card. But what we end up with is we don't know what we want to do. We don't know if we should reset the device, DPC it, replace the device. And so we have special cases, we have compromises, unpredictable deployments, and reliability problems. So when I went to our executive vice president and told him I was working on PCIe, and I just kind of looked at him and said, "Do I need to explain why?" He just laughed. He didn't even. I didn't. You know, and he's. He didn't even have to say anything. It's like, no, you do not have to justify PCIe with me. This is so painful.
are you talking about Tom?
No, I'm talking about Tom's boss.
Okay. Because me and Tom have spent uncountable number of hours just butting our head over that.
Oh yeah, yeah. But this is Amr above him, and which is good because I don't need to do a lot of work to get sponsorship for this. They all understand why it's so painful, and so the proposal here is, I think
our side is why they're asking why you didn't solve the problem.
Okay. Fair enough.
They thought you were smart, Rama. They thought you were much smarter.
Hey, the exciting thing here is that I believe we have critical mass to do ambitious things that we could otherwise not do alone. And so I am really excited about this effort because I believe that we can define the settings for PCI errors that we want at the endpoint, the device, at switch ports, and at the root port. And and Google's working on a proposal for some AER driver improvements. There are other pain points. I'm sure others will be folded into it, but we would like to upstream something that does a better job of PCIe error handling, that does a better job of logging, not just to a string buffer that we've got a regular expression parse. And then we would like to create some flexibility so when we find a surprise and we need to tweak PCIe settings, we can make it easier to hot patch a kernel and and put out the PCIe fire. And so we're going to propose that. We'll work with you all. We're not trying to blindside anyone. And we've warned people like Bjorn Helges that it's coming, and he seems pretty supportive. So if you know, he's the PCIe maintainer and happens to be a Googler. Then the other thing we want to probably do is look at the PCIe spec and see if we can clean up some of the ambiguity. We want standards for when PCI devices should use a particular error. We want to do some DPC clarification so that we can make using it the common normal case. So it's, you know, if a PCI endpoint does something ugly, we can just DPC it and turn it into a corrected error. And you might lame the system, but you don't crack it. And then there'll be other PCI improvements and you know, things like, could we have error logging queues? This is not my idea. This is just an idea I think Erwin mentioned to me, and it made such sense that I'm like, yes, I will take up your banner, Erwin. So with that, does this make sense? And then I'd like to jump in and show you what Erwin's been doing, if that's okay.
Yeah, I want to add a little bit to that, and I'm copying from what I saw happening on the CXL world, right? CXL is based on PCI Express, but just like PCI Express is, the first few revisions of the spec has so much ambiguity. And like Drew said, it was written for everybody, from a Raspberry Pi to a enterprise data center. And so what that body started to do was produce something they called a bridge spec. And so on that bridge spec, they would specify, you know, this is, for instance, if this is for data center use, then AER, just as an example, which is optional, would be required under the bridge spec. Certain error behaviors would be spelled out crystal clear, because getting that through the PCIe spec would actually sometimes be much too hard to do for what it's worth, because then Raspberry Pi consortium might come in and start complaining. But with a bridge spec, which is a body that like OCP could control, we would have a much better way. And then we could go to the vendors and say, hey, here's a spec that that we would like you to conform to, and they would listen, because there's so many players that are going to be asking for the same behavior on.
Well, that sounds good to me. Uh, thank you, Erwin. So what do you all? I mean, am I in the ballpark here? Is this controversial?
I think it's great. I think one of the points we discussed previously was with respect to best practices, like configs that would work, especially for at-scale deployments. So I think your first point in the proposal kind of covers it, but when we last discussed, Vilas was kind of emphasizing on creating a document around best practices as a starting point.
Yeah. And we can figure out what goes in the best practices and what goes in the bridge spec. I think that what will happen is if we say, hey, here's how we want to configure the PCIe hierarchy for error handling, then that will infer some expectations upon devices to behave correctly with those settings. And so the other thing that I could see us doing is developing compliance tools. And like I've been working with a company named Ant Micro to develop, we're proposing an open source PCIe air injector based on, I think there's like an AMD FPGA that can support PCIe Gen 5. And so we're talking about just taking this, making an open source project on GitHub where we inspect PCIe packets on the fly. We can do things like flip bits in them, or poison them, or trigger CRC errors, or generate URs, or force something. Make a transaction become a UR. And what we can do is we can build tests around that would allow us to inject the errors in a consistent way. And this would be an open source device. So if we find as a hyperscaler a problem with a particular endpoint or even with a particular CPU, we can share this card with the vendor. They can download the schematics and everything off of GitHub, and then come up with a way to say, okay, we have configured things the way we want to configure them. And so, if you all are interested, I can get Ant Micro to come and share their proposal here. But that's another thing we can do, is do some validation as well.
Yeah, thank you, Drew, for sending the proposal. So yeah, if we can present it, we are interested.
Okay. Thank you, Rama. So yeah, and again, I mean, I think I'm excited about the Ant Micro thing just because it's open source. And so I've done that with a row hammer tester with them, and I found something I didn't like or I wanted to add. I could just go add a feature and send a pull request, and boom, I added a new test case. So I'm kind of, if others are interested in that, let me know, and I'll see if I can get them to come here and talk to us.
Where are they located?
They're in Europe, so it may be tricky for them. They're Sweden, Poland, but we may be able to get them to stay up late one night to meet us. I don't know. We'll have to see.
Or we can have one-off meeting.
Yeah, I can set that up too. So if anyone else is interested, this would be a fairly inexpensive open source card that you can build your own tests around. And we would encourage people to upstream their tests if they use it, so that we all benefit. Okay, well, with that, I'd like to jump. I'm going to stop sharing. By the way, this slide deck is on our drive, I believe. It's shared with a bunch of you. So, you probably have this slide, and I welcome feedback. But I'm going to stop sharing. And what I'd like to do is give Erwin a chance to show you what he's done.
So, Drew, why don't you share first off, I share the link to the template that Drew and Arvind and Drew have been working on, and it's on the Google Drive also. Drew, do you want to share that, or you want Arvind to share that?
Oh, I can share. I guess it was just easier if Erwin did, so he could walk around the sheet.
Okay.
Is that okay, Erwin? I mean, like that way you can. Erwin can show us what he wants to show us.
Yeah, I can do that.
So I think it's easier for Erwin if Erwin drives, but whatever. I'm flexible. And so by the way, Neil, I know you joined a little late. I did mention the in-band stuff, so we do intend to get to that today. I talked about it already, but we just started with this since we have the right people.
Okay, yeah, that's something I was about to.
Yeah, sure. Sorry, Anil, didn't mean to interrupt. Yeah. We can come back to that, and I think we heard the summary of it, and I think we all agree with that. Let's just start capturing the pain points and start reviewing those and add to the next revision of the contribution, right? So we all agree with that.
Just so you know, Anil, I gave them a summary of our conversation, and I told them I'm actually more excited about in-band than I thought I was. So I'm eating my words.
Okay.
No, to tell you other way is all PCI is in-band. That means you are solving the in-band problem.
Yeah.
Okay. So
yeah, but we should talk about both.
Yeah.
There's a race condition problem.
Yeah. So Anil, sorry. So Arvind, just this is the initial template that you guys have created, right? So you're reviewing it and looking for, I think we all will have inputs and sessions to perfect it, right?
Yeah.
Yeah.
Yeah, and so today is just talking more about the template and what we want to capture, because almost any one of these errors, we can easily rat hole for a whole hour.
Yeah.
So that's try to keep that to a minimum. It'll be hard, but basically just keep that in mind.
Arvind, quick logistic question. Is this already uploaded to our Google Drive or you plan to do it?
Yeah, the link I sent an email with the notification where to find this file, and also the link is in the chat, Anil.
Perfect. Thank you.
And basically this template I'm slowly filling in, like Drew was talking about. It's partially filled in. You can see a bunch of TBDs. And so we'll go at it. So column A is all the quote unquote errors on PCI Express. The first four, the ones in blue, are notifications, like the report received an error fatal, non-fatal, correctable error notification. I put this first because when we start talking about error bit in particular, we have to remember that that there's a point of view you have to look at, and the general point of view we're looking at is from the root port side. So even though we could be talking about data link protocol error, if the data link protocol error was seen in an endpoint, then the only thing that you would see from the root port without a lot more digging was that there was a error fatal notification from somebody under its fabric. And then we'll generalize some of the error handling discussions later on once we see a pattern says, "Hello, you know what? All the
Arvind,
errors have a common behavior." Then we can maybe do something about it.
one question, like the goal of this one is like list all type of errors. Okay. Like you're looking at upstream port. Can you explain a little bit goal of this spreadsheet?
Yeah. Well, let's get there. Give me a second.
Well, and if I may, it's really, we want to come to a common understanding of what the errors mean, what we should do about them, and what we need to log to figure out what caused the problem. So, yeah, how do we avoid all the surprises I was talking about in the previous slide? I think understanding these errors better is the answer.
Okay.
Yeah. Okay, so so we'll go through the columns first, and Rama, that'll answer your question.
Yeah.
So the first several columns in blue are PCI Express spec information. The error itself, basically all the error bits in the uncorrectable error status and the correctable error status registers, plus the notifications, and then added one more link bandwidth notification, because that's often forgotten because it's not a error bit, but it, from RAS point of view, that's something that we're interested in.
Hey, Arvind, do you want to
Yes.
go over all the column definitions before we talk about the errors?
Yeah, that's what I'm doing. And then, then column B is just nothing special. It's error description. a lot of it's taken from the spec, but we all know that the spec isn't the most clearest, and so right now what we have is from the spec plus Erwin's interpretation and thoughts. Column C, completion TOP. This is for future discussions. It's going to start mattering when we start talking about RPPIO and advisory non-fatal. So even though most of it looks like NA, you'll see that, for instance, on non-fatal errors, we'll actually start having data that are shown. Then is the error correctable, or correctable? That's just that, and what the default severity is, and also some of Erwin's thought on whether or not we should do something different. And I'm just gonna leave it at that because that way, we'll end up talking about that error for too long. All right, so that's from the spec, and then the green ones this is the suggested hardware behavior when detected by the different device types. So the root port switches have an upstream port and several downstream ports. Endpoint, and then RCC is another flavor. RCC is another one that's often forgotten, but I want to bring it out because it's significantly different. Even though it looks like a root port, it's one that doesn't support DPC.
Can you give some example for RCC? Is just it can be root port of which level or something, but it does not support DPC.
Well, it's RCC is root complex error collector, and so usually on a root port is a parent-child relationship. There's a the root port has a BDF, and then a secondary or subordinate bus numbers would you have a device directly under it.
Yes.
But
I got it.
Yeah. Okay. And there are discussions in here, and most of the comments on here, don't freak out. This is based on a lot of discussions I was having with Drew, where the goal is to have maximum containment with maximum uptime reliability. And so a lot of it is, in order to accomplish containment, most of the discussions on DPC. But DPC has a bunch of other baggage, including a lot of things that Drew said about Linux upgrades or OS driver upgrades, because it's no longer just hardware. It's like 20% hardware, but 80% the rest of the software stack needs to do the right thing.
And that may be something we want to like I think what will come out of this discussion is that we'll say, wow, if we could just use DPC, we could turn all these fatal errors into corrected errors, and our uptime would go up, and we could contain a bunch of problems and have better error containment and less silent data corruption as a result. And so what we may end up doing is going, let's clarify how DPC is supposed to work in the spec and in software designs so that we can normalize its use. But that may be an outcome, right? That we would get out of this. So
Yep.
So sorry, please keep going. But this is really exciting to me. It's hard to hold back.
Thank you so much. Yeah, I really love it.
Yeah, and so a quick example of like the differences between a root port. I'll use DOP just because that's the first one, right? So if the root port detects the DOP error, and with DPC enabled, and the software goes in, we'll know exactly what the error that caused DPC was because it was in the root port. So we'll be able to read the registers, the root port's error registers and say, hey, there's a data link protocol error that caused DPC. But if the data link protocol error was detected by any other device, then so what will be sent to the root port is the error fatal notification. And again, assuming that we trigger DPC on error fatal notification, the only thing that you'll know at the time of the DPC is that there was some sort of fatal error coming down from the fabric. We don't know what it is, and it's worth a fairly good discussion on DPC on what we should do on those situations. For instance, should we bring the link back up just so we can read what the error register was? Why is that a good idea and why is that a bad idea? And then, of course, we end up talking about RCC, and I think I should add another column. Speaking of this right now, RCIEP, which is the endpoint equivalent of when it's in an RCC topology, is that since there is no DPC in this case, what's the best thing we can do in this? And so on the data link protocol, right, the best thing we could do without a spec change might be to just, bring the system down as fast as possible. Any questions on the greens?
That means what we are targeting until row J is, hey, which errors we can recover with the DPC flow.
Yeah. Well, yeah, that's what all the errors talk about. Most of the fatal errors aren't that exciting. Most of the fatal errors you really shouldn't see on the field. Malformed TOP is one of those exceptions, and UIE.
I can show you the data. Like,
yeah.
This is why everybody is talking about PCIe, because this is also one of the critical pain points. Yeah.
Yeah.
For scale of like hyperscalers, like probabilities becomes real.
Yeah. Yeah. And so the problem with this is that, is a quick tangent, is that some of these fatal errors, you just can't trust your IP anymore. This is so fundamental that, if the ACK-NAC protocol isn't working, I just want to trust the card, and I want to bring it back up online. But not all the errors are as severe as that, or unfortunately not as clean cut as that either.
But I guess I'm really excited about the chance to work with Erwin and the rest of you to come up with standard ways of wanting to act on errors. And even if we can't trust the IP today, maybe we can over time build expectations through some supplement like you were talking about that says, okay, for a data center compliant card, we do this. And if you want to be in the data center, here's how you need to signal errors or here's how you decide to signal a particular error.
Yeah.
I think one more comment I want to add. Can we add like one more column? Like last week, Drew, hey, we started putting in that best practice guide. Hey, when this error happens, right? What are the repair actions? General repair actions, right? Should we add that column? Yeah.
Column Q.
Okay.
Yeah. So I think it's unpopulated, but it's there.
Okay.
And there's data that we need to log, and there's all sorts of stuff. Yeah.
Yep.
Okay, maybe finish the columns then.
Yeah.
Oh, the colors went away, Erwin. What?
I know. Well, I was not gonna touch my version and touch the Google Doc version, but yeah, I just realized that the Google Doc the colors went away. But,
Okay.
yeah,
So yours is Excel, and what is the difference?
this is just, I think,
Opening, it's an Excel spreadsheet open in Google Docs.
yeah.
Oh, okay.
But we can make it either native Google. Well, that's all I got, so I'm kind of stuck. Sorry, Rama. But
I can give you a free copy.
I may ask you. Let me take you up on that.
That's industry collaboration.
Yeah. But so I hope you all see why I'm so enthusiastic about Irwin's work. I think this is awesome, and if we could, and AMD folks, I'm not putting you on the spot here by working with Intel. Carlos, I would love to, like come to a common understanding so that we all do the right things and don't surprise each other, and all of our products work together. So hopefully that makes sense to folks.
Yeah, it makes sense.
So a lot of this is not Intel or AMD or ARM. It's more IHVs. And so the next few columns, the light blue, is what I've experienced, what I needed to make a proper diagnosis. And there's another sheet here that talks about that. So in general, like if Drew comes and says, "Hey, I saw this error," and all they tell me is what the error was, right? The PCI Express AER capability registers. Sometimes I come back and say, "Hey, that's actually not enough." And so in certain errors, it's actually very beneficial to have all the PCIe capability registers. And then Poison, which is a pain in itself, Poison TOP, is one we could probably take a day to talk about. We want actually the legacy PCI error registers as well, to help with Poison through isolation, especially if there is a switch involved, because if you have a product with a switch involved, the data that goes into the upstream port gets put into a buffer before it gets routed down to the downstream port. And anytime you put something in a buffer, you're susceptible to bit flips, which then becomes a source of poisoning. But
Like here you meant capabilities is all AER registers, it's status registers, not just capabilities.
yeah, actually, we want all AER registers, especially it's easier. I don't think there's any AER registers that we don't want, but beside the status registers, the TOP header registers, all the TOP registers are really, really important for quicker diagnosis. And that's like one of the ones that we're talking about the bridge spec. What's optional, for instance, if a endpoint sees a completion timeout, just as an example, the original PCIe spec for the longest time, because it was quote unquote too expensive for IHVs to do, they didn't save the TOP header logs. And so in order to debug this, oftentimes I was asked in and I'd had to bring in the $100,000 LeCroy PCIe analyzer just to figure out what addresses was causing the completion timeouts to occur.
And that doesn't work at scale. So
that doesn't work at scale, yeah. I forgot which spec made it optional to be able to log in the TOP registers. But if you have a bridge spec, we would say, hey, this is not optional. We actually want this because of the amount of time that it saves us in debugging. And sometimes, to be clear, a TOP transaction usually has a requester TOP and sometimes a completer TOP. We have to be very specific about which header do we want to log, the requesting TOP or the completion TOP? Because I think oftentimes the completion TOP is logged. That's not very helpful because the completion TOP doesn't include the original address that triggered everything. So all sorts of things that we can put into the bridge spec, technically already in the PCIe spec, but the bridge spec would help. And then if DPC is involved, then we want all the DPC registers, including eDPC, so the RPPI registers, if they are there for debugging purposes. And at least I think one of the ones that is not thought of a lot is the software aspect, firmware. We actually want to know what the firmware is. Otherwise, unless you have very good control, you could have different firmware versions of the same card, but with different firmware versions out on your data center. And if you're seeing errors only showing up on a particular firmware, that's a big clue. Hey, something's wrong with that firmware version.
How do I get this data?
So the only way I know of is through VPD, vendor private data. That's in the PCIe spec. And I think there's an MCTP binding that also has this information.
Okay, what you're saying is one, I can use the config space or out of band MCTP.
Yeah. And then in band you could use VPD. The problem with VPD, at least when I was an active developer, was that there was a good number of devices that implemented VTD in such a way that when I tried to access VPD, it would brick the card. And that made it so that I couldn't ever, and I was never, well, as a developer, never been able to enable VPD because the risk of breaking the card was too high. And so that's something that, if this OCP wants to have, it's definitely something good to put into the bridge spec. I don't know if I don't know if this has been fixed with the newer vendors, but this is just my experience with PCI Express 4 and below. Yeah. So that's this column, the data desired known for diagnosis. And you can see in Poison TOP why I'm saying, okay, I want the PCI Express stuff, but I also want the PCI registers just to explain and put in some try put in notes exactly why I'm looking for legacy PCI. Why isn't the newer, better PCI Express error registers enough? And there's a brief explanation for that. And then there's a desired OS action, and then for right now, I can only think for the non-RCC path, the standard root port and the RCC path. A lot of times I just say, hey, DOP, and I say DOP, which was to use data-link protocol errors. It gets really, really exciting and difficult to talk about when we start talk about, for instance, unsupported request. What do we want the OS to do? Will we ever be able to see a time where unsupported requests aren't masked in 80% of the production environments? Because this is because of the probing issue, right? We're forced to mask URs in general, and we're missing out key telemetry when that happens. So that's a big discussion we can have, and it'll tie in with a lot of it will tie in with what I was mentioning before, RPPIO, which is in the EDPC. That's the E in EDPC. Where that could help, and where there's, in my mind, still things missing.
Like one question. Thank you. Actually, this is really helpful. Thanks for putting together. One question, like one is like, if I see the concept, so one is like DPC flows, right? What kind of debug telemetry required? Okay. Third thing is, what are the service actions? There are three concepts we are trying to cover for each other. Correct?
Yep.
Okay.
Yeah. So
and
I had some. I didn't put them in here. There's a. I had I'll eventually add it in, but there was another sheet that talks about what the exact DPC flows, what the OS interaction is. If you're going out of band DPC handling.
Yeah. One comment I had. This is really good. Actually, there was I think last week maybe you were not there, started putting together on the repair health actions, right? Okay,
Yep.
and like started putting. Anil also added some things already, right? I would say maybe like Anil and Drew can comment on another. Right? I would say like the priority for our discussion is like repair or health actions, then the debug telemetry and DPC. The reason I'm going in that order is, okay, like what can we do now, okay, and what data we can collect, that takes some time. End-to-end DPC building, right? It is a very big discussion. It involves like a root port level DPCs, because if there is a accelerator device versus the stack readiness versus network device or storage device, DPC flows are already like tested, well tested, right? The DPC flows trying to productize, like that is we need a lot of discussion on that. My priority order is like that. One is like, hey, if you see this error in the fleet, what are the possible repair generic actions, right? Filling the column Q, then like KLM, what is the telemetry, like we need to collect and help them the DPC. I was thinking to that, maybe Drew and Anil and others, you can add on your feedback.
Well, Rama, I generally agree with you. One thing I would say though is I think the other thing I'm really eager to see is, how in the world do I want to configure the severity of these errors? Because
Yes.
what do I do with a UR? And like right now, I would love to know how to set up which errors to mask, which errors to promote to fatal, so that things work. Because like everyone was saying, you have to do something about URs, or you're going to spam yourself to death, because URs can be like gigantically benign, or they can be kind of something that says the transaction failed. And so I think I agree with you, Rama, in general, except I would like to add that I want to know how to configure errors.
Configuration. Yeah. Sorry, I missed it. I missed it. Configuration also critical. I would put it like maybe that is like first or second. Yeah.
But how do I put my OS with the PCI set up right?
Yeah. How do I put these systems with right configuration first? Yeah. I agree. Yeah.
So
along those lines, there's another consideration, right? So right now we are thinking of one configuration for the fleet, but I think we might need to have different considerations. For example, for storage configurations or storage devices, and also in certain cases of GPU usage, we may have more leniency for certain kind of errors. We may not need to bring down the system. In other words, so for example, you have a training algorithm running, it may be more tolerant to certain errors, right?
Yeah, no, that's absolutely needed. We actually started that way in the very beginning, and then you would quickly see that the matrix blows up, and then we would just spin on that type of discussion. So we kind of just said, draw a line we're gonna talk about this generically, and start somewhere. But you know, obviously, you don't want to DPC your main storage device, because then you're gonna have many other issues.
Well, and DPC isn't universally usable anyway. So,
Yeah.
But I think Rama, what or Yogesh, what I'd like to do is kind of baseline on the sheet we've got here, and then if we need to branch out into special cases, we can. I'd like to see if we can, like, maybe just make some simple rules for the special cases. Yeah, I want to try to simplify it as much as I can, because the problem is when the BIOS boots the machine and sets up the PCI AER hierarchy, I don't know that the BIOS really knows that this is a storage device, this is a network device, this is a GPU. And so I think maybe we have to, encode something in the through ID EEPROM of those devices in the future to give the BIOS a hint as to which AER configuration it uses based on a spec we create. But that seems like it's going to be kind of hard. I'm not disagreeing with you. I just don't know how to do it.
No, I agree, and I agree with Irvin also. If we try to tackle everything, this will just explode. It almost seems like we need different personalities, and you are thinking actually even finer granularity than I was. You're saying within a system. I was thinking, I was imagining there is just a pure storage box. All the devices are storage devices, right? But you're thinking within a box you have a GPU and a storage device and a network device and whatnot.
Sure. I mean, I'm going to give you a super secret thing about you, Google. This isn't secret. I'm being sarcastic. But I tell you what, I promise you that every single Google machine that has a GPU also has a NIC. You know?
Yeah, of course. I mean, that's NIC is in every device. But,
only one NIC? Only one NIC?
Well, yeah, maybe more than one. That's fair. But I guarantee you it has a NIC.
Yeah,
it's a NIC and a smart NIC. So no, I think that's also something to think about. How do we identify device types and create personalities? Maybe that's something to think about. But I think this is a good starting point: a generic understanding and baseline, and then go from there.
So I'd like to make sure we leave a little bit of time for Neil at the end here to introduce the in-band work. But I just want to say hats off to Erwin. I was so blown away when he started pulling this out that I begged the folks at Intel to share this with you all, because I feel like this is the kind of alignment we need across the industry to really solve our pain points. So I hope that you all, I hope I didn't waste your time by pushing this, but
no. Thank you so much. Really appreciate it.
So that's a good point. So what we can do is, I think this discussion will go on. I think, Irvin, you covered most of the critical column headers, and the link to the file is in the chat and also in your mailbox if you have subscribed to our group. Let me know if you have any difficulty accessing it, and then start commenting on it, and we'll continue with that.
Like one pick. I think configuration, that one is missing, like what Drew mentioned. And Anil, like you started putting other table, like we can all put into this one all the repair actions. We can update here, merge it here, like so that we can use one document.
Yeah.
So you can add comments and suggest what columns need to be added, and we can definitely we need to have everything captured in one document. So
yeah, and that was why I made this really urgent with Intel. Is like, hey, wait, other people are making things, and Erwin's done so much good work that I was hoping we could leverage. So thank you for your patience, everyone.
Yeah, the table that I have, right, there is nothing that is not here. Maybe I would say that a column, there's a repair action, right? Yeah, so I see the last column repair action, right?
Maybe I would say move that one to a little bit early. So
yeah, so I can update that because I think what is missing, not missing. Column is here, but there is no data here, right? So, and what I did was
Rama,
I added data.
Yeah. Rama, you want the repair to take place before the error occurs, huh?
Yeah.
That's the predictive fault.
No, the reason is like whenever like I get timeout errors, all the CPU vendors like in x86 ARM says, hey, first replace the PCI card before you give the warranty. You return the CPU, right? That is not a good. That is not a good like for us like hey, like unless we improve this one, what happens is like they're unnecessarily replacing CPU. That we want to. That is the other. Yeah.
Yeah, I feel like, yeah, Ram, you pretty much nailed it. Our default action is we don't know what's broken, shoot the messenger, and the messenger is usually the CPU. So, and that's bad. It's not the right answer.
Yes.
Yeah. Well, what happened? That's not what I was saying. I keep stressing firmware and software be part of the action, because what people usually do is you're kind if you just shoot the CPU. What end up people doing is that they replace the CPU and the card that they think is affected, and hope for the best, because the worst thing to do is to have the system go down again, and then it's like now I only replaced the CPU, now let me replace the IO card. What people are forgetting though is that there's a firmware component and there's also OS component that could be contributing to the issues. And when we get to some of these discussions down here, we will definitely dive deep into what the desired OS action and what the health repair, what the health repairs are.
Sorry, Arvind. Great work. I just want to give it to Anil for rest of the time.
Yeah.
If that's
Okay.
I'm so sorry, Anil. We did try to cover your thing first, but a little bit. I did brief them. But if you want to show the pain points, and maybe if we could come up with what do we need to do for next week to enable you to make progress, that would be awesome.
Okay. Yeah, I think we have only 3 minutes left, right? So let me just kind of share my thought process. I don't think I can go over all the work.
Well, do you have a pain point document you could introduce to us so that we could start working on it?
Yeah, so what I did here, you can see what I'm saying, right?
Yeah.
So in work in progress, I think I created in-band fault management infrastructure requirement. This is the document I have created. Okay. And I think it should be available to all the folks. Let me see, make sure. Yep. I think everybody who is on this drive should have access. Anyone with a link, commenter, I would say editor. Your access may have been changed. Interesting. What is going on?
That's okay, I think.
You're the owner. I don't know. That's weird.
Okay. Anyway, maybe between Rama and Drew, you can help me kind of make this available to everyone. Yeah. So what I did actually is I kind of use the same format as we have our OCP fault management document, because my thought process is that once we have put together the in-band requirements, we want to kind of bake in into our existing document and call it like revision 1.5 or something like that. Yeah. Because there's a lot of overlap, a lot of synergy between what we have already done for out of band and what is needed to add in-band part.
And I mentioned that earlier, Neil, that you and I had talked, and that we were going to try to fold the in-band stuff into the current doc and just have one doc. So I think everyone was aligned. Right.
So with that in mind, I kind of kept the same headings and all that, but the text is obviously I kind of changed it. So this document defines requirements for a system architecture to monitor, report, and remediate hardware component errors using in-band methods. And it first provides an overview of existing in-band methods and clarify the gap that exist, and finally recommends addressing these gaps. That's kind of thought process.
Hey, Neil, in the spirit of saving ourselves work, I think it'd be a little tricky to merge something that is worded like this. If we said this section, it might be easier to merge if we, because it's going to be a section of the document will be in band, a section of the document will be out of band, and so would it be possible maybe even just to start adding sections to the existing document so that it makes merging easier? Because
I would agree with that. In fact, what you can do is go to that document in existing sections. You can just add subsection kind of thing in by considerations. And
or whole new major bullet points if you think you need it.
Yeah.
I guess, Neil, I would encourage you start writing the main document, like you're the owner.
So that is something I remember I was asking in the earlier meetings, and the consensus at that time was, no, let's start as a separate document first, and then at some point in time.
It was always no. I think there was some misunderstanding. I think the idea was continue with the same document, start adding stuff in that document, but I think one disconnect there is, I think I did say that, yeah, let's start reviewing and then start adding, right? So I did not expect that you'll actually have a separate document. So with that, I think, yeah, there is a little bit of disconnect there. So how do we do that?
So
You can start
solving,
adding and then start adding and then we'll start reviewing. I think I agree. There was that. Yeah.
I think I liked the earlier suggestion. Let's start as one separate document first. Let's get the thought process all together, and once we have some one or two, or at least 2 or 3 iterative reviews, have some mature data, then we can roll it into the main document.
But that's going to be more work. So can you write this like it's a section of the existing document to make it easier?
Yeah, only risk, Anil, that is if you do that, you'll spend a lot of time writing as a standalone document and we'll end up throwing away a lot of it because it's going to be repetitive or duplication of what is already there. So it's your call, but I was anticipating more like just the pain points discussion, but this looks like a whole requirements in itself. So
okay, yeah, so I can try that. I can merge it into the existing document. So yeah, so I think one thing that maybe, I don't know, we have time, we are already 3 minutes past here, is something that I want to kind of share. 2 things. One is I took a liberty to draw. I'm sorry, I didn't get a chance to review it with you separately. To modify this high-level concept. So what we had earlier was the out-of-band hyperscale BMC and this flow, right? And what I did here is I added in-band with the standard logs and actions and calling as the in-band agent. And then after that, the rest everything is same.
Yeah, this is not controversial with me at all, and I would love to just put this in the main document. We'll iterate on. The only thing I would change here a little bit is maybe some color coding or something to show that the in-band management agent runs on the host CPU. But the draw overall, your changes look great. I'm not controversial at all.
Okay, cool. And then the second one I want to just quickly share here is the big diagram. And here what I did, Drew, this one you and I discussed offline. And so what I did is basically I earlier we had OS kernel, right? And then application on top of that. So what I did here is I added an in-band management agent. And one thing that didn't show up earlier was device-specific error handlers. I know there was GPU, but this is all out of band here. So maybe you need to kind of clean this up by calling as a, GPU NIC within that in-band and out-of-band, right? So, and generally the device drivers are sitting at above the kernel, right? So I think it probably would make sense to show something like over here as a device specific.
Let me take a stab at this. I like the direction you're going and agree with what you've done, and I agree with what you're saying. It's kind of a pain to work in the drawing tool, so I'll work on that if you don't mind and try to polish it and I do exactly what you're saying. I'm aligned with you, Neil. And another thing I would add here is that we need the in-band management agent to connect to the cloud provider infrastructure somehow.
Yeah,
Like,
I didn't know that yet. Yeah.
Yeah. I knew that wouldn't be controversial with you, but let's work on it. I like what you're doing.
Okay. Just to sake of simplicity of drawing, we may be better off, especially for the big picture drawing. Just create an in-band version and out-of-band version.
Let me take a stab at it, Yogesh, and see what I can do.
Okay. Because the open VNC is a big chunk in the middle. If you have to kind of, you can try.
It's a problem.
Like, sorry to interrupt. Like, I think there are some new joinees. I also invited like.
If they're here,
NVIDIA. Maybe next week should we
if they're
go with
here
their
6
introduction?
minutes.
Yeah.
If they're here 6 minutes past the call, they're really committed and they do deserve it.
Yeah, we need to start with next week about their introductions, and I see Dane and a lot of people, and I forwarded to people this invite.
So sorry, welcoming everyone. Sorry, we just jumped on. Normally we do introductions. Today we kind of had a packed agenda, so we jumped directly on it. So I see Sean, Victor. Who else do I see? I think we lost some people. I think there was Harita.
There is one person with last person with some Chinese, I think, characters.
Korean, right?
Korean, yeah. Could you please introduce? I'm not sure who that person is.
Oh, you're on mute if you're talking. Well, let's do introductions next week. I am so sorry.
Next time. Welcome all. Sorry, we did not do introductions today. We'll do it next.
I'm sorry. I was so enthusiastic about today's agenda. I just kind of dove in, but honestly, I'm really fired up about the work Anil is doing. I didn't think I would be. I'm eating my words. I'm pretty excited to see what's happening here, and I would just want to thank Intel and Erwin again for awesome contribution this week. So
thank you so much. Yeah.
I hope that your enthusiasm, if other folks are as enthusiastic about this as I am, but I think this is pretty good stuff.
Thank you all others joining. I think we're running out of time.
All right. See you all next time.
Sounds good.
All right.
See you all later.
Yeah.